Alright, this is Chapter 7, Section 1. This is the second video. So we proved in the last video the central limit theorem actually works for us, which is basically even if the distribution is not normal to begin with, right? It's not normal to begin with. Or if it is normal to begin with, if you take larger and larger sample sizes, it becomes normal. It's just the standard deviation becomes smaller, and it becomes smaller by the square root of n, which is the sample size, essentially the standard error. Okay. All right, so similar symbolism to Chapter 6, except this is sample mean, right? Whoops. This is sample mean now, right? See the bar on there? It used to just be x. It used to mean the data was, this is referring to the data. Now this is referring to the data samples, right? Or approximately normal, right? So the sample mean, right? And this is the, standard error, essentially. Okay. All right, let's try some problems here. So what does this actually mean here? So if I'm looking at this, this means so if the following represents IQ data of children in middle school, explain what the following means. So the sample means are approximately normal. That's what it's saying, right? Sample means are approximately normal. The mean of the samples is 82, with a standard deviation of 7 and a sample size of 64, right? And then this whole thing is the standard error. Okay? So the samples, data samples, right, are approximately normal with a sample mean of 82, standard deviation of 7, sample size of 64, and this whole thing is a standard error, this whole fraction right here. Okay, so let's say we have a very generic problem here. This is saying the sample size of 25 is drawn, okay, from a population of who knows. Its unknown distribution is a mean of 9 and standard deviation of 15, right? So essentially that is what we're saying if we convert it to symbols, essentially. Determine the sample mean is between 85 and 92. Okay. So the sample mean is I took 25. What's the chance I took 25 of these random things and their average is somewhere in there, right? So let's go to there and calculate. All right, so we want to do normal dot distribution, right? So 92 comma 90 comma 15 comma true minus normal dot distribution 85 comma 90 comma 15 comma true. Okay, so this is the way you do it in Chapter 6. If you selected one random object from this group, what is the probability it's between 92 and 85? I'm not asking that. I'm asking for a sample mean. So if I take a group of 25, what's the probability it falls within this range, right? So the mean of the individual and the mean of the group is the same. However, the standard deviation gets smaller. It gets smaller by the square root of the sample size, right? So we have to manipulate it by doing this, right? So now this is saying, what's the chance the sample that I take is between 92 and 85 for a sample size of 25, right? Which is a different question. So about 69.97, essentially, okay? All right, so you have to distinguish Chapter 6 versus Chapter 7. Are we asking about an individual being selected or a group being selected, right? Determine the value that is 2 standard deviations above the expected value for the sample mean. So we did this before, except I've changed one little phrase here to sample mean. So 90, which is the average, right? Plus 2 deviations above, correct? And 15, which would be our standard deviation. However, that would be for an individual. Divided by the square root of 25, okay, would be the group, correct? So that's going to be 5. So 15 divided by 5 is 3, times 2 is 6, so 90 plus 6 is 96, essentially. Okay? All right, so this should be labeled 96 something, but I don't know what these somethings are. What the hell's going on? Oh, I pasted it more than once, that's why. Okay, but I don't know what these somethings are, so we're just going to go with that for now, right? All right, so let's take some ones that are not generic here. Let's say we have an SAT, and the hours it takes to take the test, length, the time of the hours in the SAT is normally distributed with a sample size of 60. Okay, so if we're going to write this in terms of the correct symbolism, it would be this, correct? So the samples of SATs, right, that's what this is saying, the samples of SATs are approximately normal with a deviation of 2.5, I'm sorry, average of 2.5 hours, deviation of a quarter hour, and the sample size is 60 students taking the test, essentially. What's the probability of the sample being between 2 and 3 hours? Okay, let's go to the next one here. So normal dot distribution. So between 2 and 3 hours. So 3 comma 2.5 comma 0.25 divided by the square root of 60 comma true minus, I'm going to cheat and copy this, paste that, and put 2 here. So this is asking if I took 60 students, what's the chance that that group on group average would be between 2 and 3 hours, essentially, right? This goes always higher minus lower, just like chapter 6. So we got a 1, right? Is it a 1? I don't know. You can set it to number, right? So it's a number, and then just keep going out more decimal places. Eventually it might change. Who knows? Just make sure you got enough places to check that. So essentially when they did the SAT, they figured the probability of a group taking a test when they would finish. They figured, you know, the 3 hours would be more than enough based on the statistics that they figured out. Okay. All right, let's try a couple more here. Let's say the study of a user's tablet users found the average age is 34 years of age with a deviation of 15 years. You take a sample size of 100 from the population. Okay. So essentially, my sample mean is 34. Standard error is 15 divided by root 100. And again, don't, if it's like 17 or something like that, don't do square root of 17. Just keep it as the radical. Don't be estimating. What does the sampling distribution look like? Okay, well, I'm going to say that it's approximately normal because the sample size is more than 30. Okay, so notice it does not say in this problem anywhere, does not say whether it's normal or not. So in the original problem that I had made up with the 4 kids taking the quiz, it was not normal, but it became normal. So as long as your sample size is 30 or greater, you're typically okay. Is that the real way to prove it's actually normal? No, but for the sakes of stats 1, we're going to say that 30 is big enough. So you're like, well, the example that I did on the first video was only size 2 and that worked. Well, that was a very specific example that I made work for size 2. Typically size 2, 3, 4, 5, 6, something like that, small sample sizes are not going to be enough to make it actually normal. Typically you need bigger sample sizes. So for the sake of stats 1, we'll make a nice 30, which is a rule of thumb, but not the real way to do it. We'll say 30 is enough to make it normal. In stats 2, you can go through the processes of proving it's actually enough for that. So essentially, if you don't have at least 30, you can't necessarily assume that it's normal. Okay, so we want to know the sample mean, right? So sample means that's a sample of 100, right? Is more than 36 years of age. Okay. So if I do that, I'm going to do 1 minus normal dot distribution, right? More than 36 years of age. The average was 34. The deviation was 50, and the sample size was 100. Okay, so what we're saying here, because again, you can draw the pictures just like chapter 6, right? So if I draw the just like chapter 6 here, right? We're saying 36 years of age or more. What's the probability, right? So if I did this, I would just get this area right here, which is not what I want. I need 1 minus, so it'll flip and get the other side essentially, right? So I'm going to get about 9% essentially. Okay, so what we're saying at the end of the day is the sample of 100 guys or people if that sample was 36 years of age, that's only about a 9% chance that that's actually going to happen. All right, so what's the 95th percentile of samples? So if I take a sample of 100 people, okay, they use tablets here, I guess. What's the age of that sample if it's the 95th percentile? So that's a pretty older group, right? Because lower percentile would be a younger group, 95 percentile would be the older group, right? So what is that number essentially? Okay, so normal dot inverse 0.95 comma 34 comma 15 divided by the square root of 100. Okay, so 36.47 or 4672 years essentially, correct? All right, so what essentially we're saying is if I took a sample of 100, if it's the 95th percentile, it's that many years age is the average of the group essentially. If it was the 96th percentile, it'd be higher than that. If it was 94th percentile, it'd be lower than that essentially. Okay? All right, let's try one more generic example here. So, you create an app for tablets, and one of the things they care about is engagement in the app. So the average user is 8.2 minutes with a deviation of 1 minute, and using samples of size 60. So what is the mean and standard deviation of the sample? Okay, that's 8.2 and 1 over root 60 minutes essentially, right? So what is the standard error? Okay, well that is what we already did, right? Okay. So don't get those confused. Standard error is when you start doing this with divide by the square root of 60. Okay. Determine the probability the sample mean, right? So that's the 60 people, correct? Is between 8 and 8.5 minutes. So the average is 8.2, right, which is in there. So I would guess that's a pretty high percentage because the actual mean is in there, correct? Okay. So let's go to, we're still on page 4 here, right? So let's do normal dot distribution. So 8.5 comma 8.2 comma 1 divided by the square root of 60. Okay. Comma true minus, I'm going to copy this to kind of save a little bit of time here. Paste it, and we're going to say 8. So what this is saying is of the group of 60, what's the chance the group average is between 8.5 and 8 minutes is essentially what this is saying. Okay, so that's my probability that I'm between those two values. Okay. All right, so next is saying determine the 90th percentile for the sample mean time on the app. Okay, so the group average, what is that average amount of time on the app if it's the 90th percentile? Okay, so normal dot inverse, or inverting the 90 back to an actual value. So 8.2 average with a 1 divided by square root of 60 standard error. So that is a number of minutes that my app should be at the 90th percentile essentially. Okay. So the group average of those 60 people . There we go. I don't know why that keeps happening. There we go. Okay. All right. So long story short, okay, invert it if you want to figure out the actual value, and then do the distribution, which is the normal function we covered in chapter 6 to figure out the probability, right? The same premise applies as chapter 6, left to right, but the only difference is this. We're talking about the group, right? The sample mean, the group, versus the individual. That's the basic difference.